Then you type Java C. Java C. Let me show you on the screen now because I just finished installing mine now. I run as administrator. Before it was showing cannot be recognized. So once I just type JAVAC and press enter, now it's giving the list. So this shows that Java has been installed. Yeah. Good. So the next thing we'll do is we can close this now. Let's quickly go to the objectives. One of the major objectives of what we are doing is embedded in giving you skills, not just to pass your exams, but skills you can use for a very long time, for a lifetime. It's not just for you to prepare for an exam, but it's also for you to be useful, for it to be useful in your productive, in the productive aspect or category of your life. So today we're going to be looking at computers, what they are, the hardware, and then we are focusing more on the software because this is a coding class, and the importance of you knowing the fundamentals of what programs are cannot be overemphasized. Who can tell us what is a software? What do you understand by software? What is a software? What do you understand by software or coding per se? What is coding? Anyone? Speak up. Inner part? No. It's not the inner part. Anybody else? Yes?
The software is part of the computer which you cannot touch or
Okay. Now I want you to pay attention to this. These are part of the things you know. You guys you all have ideas of what software or coding is. Alright? So that's why I need you to pay attention. And if you have your biro and paper, ensure you write down these key points as we progress. Now, as you can see on the screen, it's telling us here that this is an electronic device. That's a computer. It's an electronic device operating under the control of instructions stored in its own memory that can 1. Accept data, 2. Process the data, 3. Produce results, 4. Store the results storage for future use. If you are asked, whether you are asked formally or informally, this is how you are expected to give an answer to what a computer is. And you don't need to, memorize everything. The most important thing is you say it's an electronic device, all right? It has instructions, okay, has its own memory, and then has these functions: accepting data, processing data, producing results, and storing the results for future use. That's all. It's not hard for you to have this behind your mind. So anytime you ask what a computer is, this is exactly what you are supposed to give as the right answer. Now we move on to what really is a computer. Now, these are few examples of what we know as a computer. Of course, we all know this. What's this? That's a printer. Then that's the next one. What is it? Huh? You are not sure. See, this one is doing more like this as if you see eating something. What is this? The second one? Eh? Someone is saying scanner. Which one? What is it? What is this? On the screen there, that one there in the middle. Eh? Yes. That is the system unit. Some of you mistakenly call it CPU. It's not CPU. CPU is only part of that system unit, which you can see here, and you are seeing alongside this lab. So this is a system unit, system box. The next one is what? Monitor. What kind of monitor is that? What kind of monitor is it? Eh? That is just theoretical thing you're saying. This thing has a name. That thing you're seeing, it has a name. What's the name? That is, yeah, right. That's an liquid crystal display monitor. LCD. Write it down. That is an LCD. It succeeded the CRT. We'll still talk about the CRT. LC, liquid crystal display. That's it there. Then beside it you can see a keyboard and the mouse. Then speakers. There are speakers there. We're done with that. The next one is what? Well, then the next one, USB flash drive. That's the right word. Then what else do we have here? We have what? What's this? Memory card. You can see that. Then this one is what? External hard disk. Let me give you a very, very typical instance of what that is. This is it. This is an external hard disk. What is it used for? For what? To store it in. What is this thing used for? Eh? I'm not hearing anything from you. You are not even sure. To what? It stores data, external data. You can use it for backups. Don't forget, please, in case of next time. Then the last one there is what? A modem, like what you're seeing here. Like this MTN, this is what is a modem. So let's quickly go on. Now, yeah, these are examples of computers. You can see desktop, PDAs, tablets, mainframes, smartphone. Some of these things you see every day. But it's a pity that some of us don't even know what they are. You see them every day, but you don't know the name. So, as you have been sent to school now, you will be the educated guest on the street. Somebody who is doing in the streets of Lagos, walking and saying any kind of thing, there are all kinds of things. You will come and say, this is what it is. So you can stand out of the crowd, you will be separated that this is an educated man, this is an educated woman. So the right names for these things are very, very important. Now, I'm going to send this thing to a copy of this thing to principal, so you can get a copy from her. Or if you know you have an email, drop your email and I can send it to you directly. So you can read it at home. Now, computer system is only functional if there is hardware, there are users, and there are software. Now, basic hardware components. Can you all read this? 1, 2, go from the beginning.
Hardware represents the physical and tangible components of a computer.
Input.
Keyboard, mouse, etc. Output device, printer, monitor, speaker, etc. Secondary storage device, power
and then the other one, speaker. Good. Now you can see some of the devices there. Of course, these are things that many of you are already familiar with. Now, hardware components, you can see the system box. That's the power supply. That's CPU. The CPU is a component, like I said. CPU is always a component of the system box or the system unit. All right. There's a lot of things embedded in that box. Now here you have the motherboard, you have the RAM, then of course you have the NIC. What is the meaning of NIC? Who can tell me? Very good. Network interface. I don't want anybody moving around because of this camera. I want everybody to be in a place. Don't be moving back and forth. So you will not, your frames are capturing. So any movement you do is going to record. It's recording it. I need you to be steady in a place. So let's move on. These are some of the other hardware components we have. You can see the physical, the hardware, the hard disk itself. Shay, is there a problem? Can you just be still? The memory, the hard disk. You can see that's another set of hard disks there. And these hard disks, they have categories. You have the SATA drives, and then you have the IDE. All right. But that's not for today. We're not going to cover that today. But just for you to know the peripherals of these systems is very important as a foundation for learning coding programs. Now here you can see some other peripherals there. The mouse, the keyboard, the external speaker, the webcam and scanner. Then here, these are serial ports. Some of these serial ports are no longer in use. Like this PS2 there. PS2, those roundish things. The new generation of computers don't use these things again. What they use now is they use USB. It's more digital. These ones are almost become analog, with the exception of the HDMI. like this projector now, I'm using a HDMI to connect for me to the computer. This computer now is a new generation. It's fairly a new generation computer because it doesn't have these ports. This one here. This is what we call. What's the name of this port? Who knows it? Who can tell us? What's the name of this port? This one, the first one here.
Serial port.
It's serial port, but it has a particular name. What's the name?
Port.
They can ask you in any way. You can say, whether in exam or offline, they can ask you this thing. This is VGA ports. What's the meaning of VGA? Video graphics adapter. Write it down. Video graphics adapter. That is what it stands for. And that is how it looks. So just in case of next time you see this, you must be able to identify it. It's a serial port, mainly for video graphics adapter. The other one is a parallel port. That one is the old form of printer connection, but it's no longer in use. Now USBs are being used. The same thing with that one. That one at the extreme end up there is the PS2. Alright, the PS2 holds the two mouse and keyboard. That's the former ones being used. Then here you can see some other components here, like the connectors and some other peripherals. Now, then the last one there, you see the HDMI. That's the HDMI port. Then, of course, here you are still seeing the same thing. Now, arrangement of the component, you can see the components of the system box. Some of them, the external components, you can see them, the power switch, the lead, the reset switch. Alright, then the ports, you have the power sockets and the ports there at the back. Like I told you, the serial port, the PS2, they are no longer in use. So let's now move to the computer software, which is the main thing we are after here. Now, this is telling us, can you read the first paragraph there? Everybody, 1, 2, go.
Software is a set of programs which is designed to perform a well-defined function. The program is a sequence of to solve a particular problem.
Okay, now it is a set of programs. That's what is the software. I was asking you the other time now before we started out. Can you define what the software is? It is a set of programs, software, alright? Now, which is designed to perform well-defined function. You are going to be meeting functions a lot in programming, a lot of functions and classes and methods. I'll be introducing to you today. A program is a sequence. A sequence means that it's following step by step, instruction for execution. That's what it means. Now, types of software. You have system software. As the system software is one that supervises the entire system. Alright? As you can see, the system software is a collection of programs designed to operate, control. You see? Operate, control, and process the capabilities of the computer itself. Alright? It's like a supervisory software, like the Microsoft operating system, Linux operating system, Apple OS, and so on and so forth. Now, system software are generally prepared by computer manufacturers, like I've mentioned, Apple, Microsoft, and a lot of them. Then, system software serves as interface between hardware and the end users. Let's really go on. Application software. Now, application software products are designed to satisfy a particular need of a particular environment. Alright? Application softwares may consist of single program such as Microsoft Notepad for writing and for editing text. Alright? The application software, what you need to understand is that the application software are for the end users. The end users, anything that has to do with the end user, it's a utility. So it provides utility to the end user, like your Notepad, your PowerPoint, your VLC for watching movies, and a lot of them. So those are application softwares. Now, let's move to the utility software. These allow computers to perform tasks that are not part of your operating system, but are still practical and useful utilities. You can talk maybe like shutting down, putting on, or maybe like typing like Notepad and some other things like that. And some of them might come from external sources like CD-ROM or USB drives. So now, proprietary software versus open source software. When I was taking the class yesterday, I did mention, now, proprietary, there's a difference between proprietary software and open source software. Proprietary software are commercial. They are privately owned by organizations. For example, Microsoft. Microsoft is owned by Microsoft Corporation. Alright? Most of all their software they are, financially or numerically, sort of, you cannot have them without having to purchase them for sure. They are for commercial purposes, all right? So, and as you can see here, they are proprietary, they are costly to buy, they are adaptable to meet local needs. Some users, particularly in developing countries, legally use unlicensed ones. This is legally unwise. So it's always better to use software that you can actually afford. And that's where open source comes in. The open source, on the other hand, is free. You can easily download it from the internet and use it for your own good. Alright? So the open source is very typical in the sense that there is an open community or world community that maintains this software. For example, Linux and its variants. Linux like Red Hat, like OpenSUSE, like Ubuntu. These are typical Linux distros, variants that are used for personal development or for personal use or even for company use. There are some companies in Nigeria, the telecommunications company in Nigeria, like Glo. Glo uses Linux for their servers so that to reduce the expenses of running. That's why you have cheap. Glo has one of the cheapest data in Nigeria at the moment. Okay, but some others that use the proprietary, if they use the proprietary, it's most likely the cost of provisioning their service might be much more. All right, but a lot of people have said Microsoft is more friendly. That's why so many people are going for it. But all the same, all you need to know is that there are two categories of software: the proprietary, owned by companies, the open source that is free for you to download and use. Let's quickly go on. Now, examples of this software, you can see the Microsoft Windows Office, then a list of utilities, and so on and so forth. Now, let's look at the relationship between the hardware and software. Hardware and software are mutually dependent on each other. Mutually, when you say mutually, in mathematics, you talk of mutually, exclusive events or dependent events. When something is mutually dependent, that means the two of them are coexisting. That's what it means. On each other. Both of them must work together to make a computer produce a useful output. Sheye, please, can you check the camera for me if it's still rolling? Just check. I don't want you to. Okay. So let me. Okay, so like we're saying, look at now the relationship between hardware and software. Hardware and software are mutually dependent on each other. Both of them must work together to make a computer produce outputs. So they are mutually exclusive, means they work together, hardware and software. Now, software cannot be utilized without supporting hardware. The hardware without a set of programs to operate, one cannot be utilized, and it is useless. To get particular job done on the computer, relevant software should be loaded into the hardware. For instance, a device driver is needed. Now, a device driver is a program that controls a particular type of device that is attached to your computer. They are device drivers for printers, displays, CD-ROMs, CD disks, diskettes, etc. Hardware is a one-time expense. Now, let's look at the relationship between hardware and software. Of course, we are still continuing with that. Software development is very expensive and is a continuing expense. Different software applications can be loaded on a hardware to run different jobs. A software acts as an interface between user and hardware. If hardware is the heart of the computer system, software is the soul of the computer. Now, let me everybody look up, please focus on. Now, you can see I listed these as some of the coding languages and applications for your knowledge that you need to be familiar with. Number one, you can see the logo there. What is in that description? Everybody read it out. 1, 2, go. And then the application is what? Good. Then number 2, this is PHP SQL. What is this used for? This is the description. Read the description there. PHP SQL Apache. And then the application is what? Good. Number 3. Okay. For native web web apps and game apps. They are different things. Native. Anytime you hear of native software, it means a software that is offline. You should write that down. Though I'm recording this, you're going to have a recording, the full recording session. Alright? I'm recording it from two sections, from two areas, from there and then from here. So you can play back the video when you get it. So we are where? What number are we here? Are we done? Okay, I was explaining 3. The native. Anytime you hear about the native, a native software is an offline software that does not require internet connectivity. While a web application, a web software is a software that is based online. You cannot use it without internet. Alright? Examples of native software are, of course, Microsoft Word. You can use the full functionality without the internet. The internet is an option. Corel Draw, you can use it, But though these days, a lot of them come along with components or an online component. And that brings us to the third category of software programs. Hybrid. A hybrid software is a software, the kind of software that can operate online and offline. So it combines the features of the native and the web apps together. And that's what most of these softwares are becoming these days. Facebook is you cannot use it online, you cannot use it offline, you can only use it online, so it's a web application. Twitter, Tinder, TikTok, these are all applications you cannot use offline. Can you use it offline? You have to have that. So anything that you have to use data, you have to load MTN, Glo, 9Mobile, or any of the likes is a web application. Anything that you can operate on your computer, on your phone or your computer without internet connectivity is what? A native software application. A native software application. A web-based software application can only be used online, while a native-based software application can what? Good. So that is that. And that's why that number 3 comes in very handy. Now let's go to number 4. Can everybody read out number 4? The description there was there. Want to go? Kotlin, Java. Now, in the beginning, when Android phones started, they were using Java, but now the language the Android phones is using is called Kotlin. So it was produced by Google. It just works like Java, but it's the same. Now, what's the application? Can anybody read it out there? What's the application there?
For mobile apps.
For mobile apps. That's what number 4 does. Then number 5. Good. That's the logo there. What is it used for? Good. Then the last one there. And then what's the function there? Good. Now let's quickly look at this. Now this aspect is something I need you to focus on. It's very, very important. Object-oriented concept of coding software. Now every program there's something that we call objects and classes in coding. Now I want you to write down something. An object is the instance of a class. Write that down. An object is the instance of a class. An object is the instance of a class. Now, what this means is, look up if you have written that. What it means is that you, if you're a daughter, you are the instance of your mother. If you're a guy, you are the instance of your what? Father. So the father is the class and you are the what? Object. The mother is the class and you are the what? You don't have the object. Then you can also have parents as the class and children as the object. An object is the instance of a class. What is your name? What's your Nigerian name? You don't have one. You don't have Chiwe, or Chima. Or who has an African name here? Nigerian name. Who has an African name here? You are free to call your African name. So Chidebere. Okay. Now, like Chidebere and his sisters or brothers are the instance of their what? Parents. So that is just the general concept of objects and classes. Now I'm going to show you something here now. Like you can see here, I did try to make a description here, but it's not that elaborate. But this one gives more elaboration. As you can see now, object-oriented programming. You can see the class as human. For this example now, you have the class as human, then you have the object as name. So the name is the instance of the what? Good. The name is the instance of the what? Human. The name is the instance of the human. So then, apart from that, now I want to also give you this analogy. An object is the instance of the class. We already established that fact. Now, the next thing you need to know is that for every object or class, there is a property. You can also say an object is a noun. What is a noun? Who knows what a noun is? Name of a person, animal, place, or what? So, an object or class is a noun. While the property of that class, like your ear now, this ear, yes, no, this ear now is the property of who? Chidebere. Chidebere has his ear as a property. His nose is his property, his mouth is his property. It's nobody's property, it is his property. So he's responsible for it. And it's also called, what do you call an adjective in English? What does an adjective do? It describes a noun, right? Good. So I can describe Chidebere with his ears, with his face, with his nose. Those are features that describe him, adjectives. And that brings us to these properties. Every object and class every class has a word property. Every class has a word property, as well as an object too. So since the object inherits everything that the class is, then that means it also has its own properties. Now let's look at this, the last one here, the methods. Now, what do we use ear for? Is it not for hearing? Yes. What is hearing in English? Is it verb, adverb, or verb? And what does a verb do? A verb does what? It's an action word. It's an action word. So methods are verbs. They perform what? Action in coding or programming languages. Is that understood? Yes. What's your own name? Yeah. Give me. I go by African names here. I don't go by English. What's your? Olufemi. Good. Olufemi has legs that can walk. Her leg is her property, but the action that leg does is what? Walking. So she walks. And that's what the methods do. Every method belonging to a class performs action. That is that. So now look at this another instance. I'm giving you another example here. It's a class. The properties of the car, color, properties, they describe the words. Right. So what did I call them again previously? In English, in lexicon, in English lexicon, what are they? Somebody saying something there. No, not objective. What does an adjective do? Describe what? Good. And what is a car? Is it a noun or what? It's a noun. So this is describing what? Methods. What did I call method in English? What does verb do? It performs what? Action. So we have start, backward, forward, stop. These are actions that can be performed by what? The car. And they are methods. They perform actions. Sometimes they call methods functions. Now let's look at this now. Property values, you see, they now set the values now. The values. Setting the values is another thing entirely. The same variables you have here, color, price, kilometer, and model. Color, price, kilometer, and model. Then you have their values and their methods. The method here is the same thing with that. The only thing that changes is that they now assign values to them. The color, of course, there are different colors now, right? Yeah. There is red, there is blue, there is pink, there is brown, and all sorts. Good. Right. Please, can someone share? Can you check the camera for us? We're still rolling. Just intermittently check it. Once it doesn't, it's not rolling. You holler at me so that I'll come up and. Okay. Just excuse me one moment, please. Let me. So now, here is another concept of the object-oriented. It says all concepts, look up everybody, all concepts of object-oriented programming are the same in all coding languages like Java, Python, PHP, Kotlin, or for Android. Now, look at this is a typical example. Now, everybody look up, this is very important. This is Java. Look at the way they define the class. This class is called what? Hello World. What is it? Everybody say it. Class what? Now, you have public. I'm going to explain this thing as in time, as we progress. Public, when you make something public in programming, in coding, it means you are making it public, you are making it global, accessible to everything. That's what it means. Public. Static. Static means it is just performing a function. And the name of that static void is main, the main function. You see, the color is different. This is the main function. This one are reserved words, public static void. You can see the color indicators are the same. This is the name of the function. Now, these are strings that you supply during the execution of the program. But I'm going to come to this is theory. When we start the practical, you get to see. Now, here you see an object, property, and method. Please pay close attention. This is Java. Object, property, method. Object, system, out. Function is what? Our method is what? Print line. This thing now is part of the Java program. Is a class called system. Okay? The system calls its property out and then calls a function called what? Print line. This thing you're seeing means print line, hello world. The braces you are seeing here is the starting and ending for the function. This one is the starting and ending for the class itself. I want to go over this video. When you go over it, you understand it as time goes on. But let me give you another example. Now, this is C++, the object-oriented function. Now, this is a typical coding. This is a typical coding. Now, pay attention, pay very close attention. Who is talking there? Who's talking there? I don't want anybody to be distracted us. Now, this is a typical class program for C++. You have int main. Main is the main function being called. std count, hello world. This std count is saying output. This is an object in C++ calling a function saying std count. Now let me explain to you in clear terms. What did you call your name again? Olufemi is a lady. She can call any of her functions. If she wants to listen to Chidebere, she will listen to him, Abi. If she doesn't want to, she has the authority to disconnect, right? Good. Now, let's come back to this. This is a C++ class. This std is an object. And it's calling what? Its function. Output. Output, hello world. Because it belongs to it. Just like Okweyemi has her ear, she can block it and she can close her eyes, she can open it. She can call any of her functions as an object or as a class. Is that understood? So that is how this works. This is a function on its own that is called main. Now in that function you have another object that is calling, or a class that is calling its function. And the function here is what is output. Say std output. This class now belongs to the C++, one of the libraries. Okay, let me explain to you. You know what is BODMAS? Can anybody explain what BODMAS is? What's BOD? Brackets. Assuming I wanted to create a class of BODMAS, I can create a class of brackets with a function of multiplication or addition, right? Or subtraction. I want you to understand the concept of objects, because if you understand it now, you understand it for good, and you don't need to go back and forth in understanding how to write coding programs. This is very, very important. Now let's leave this and go here. Now, this is C#. This is Microsoft's proprietary. This is how to write hello world in C++. You can see it declares a namespace. That namespace is like an encapsulator. It encapsulates, like it holds everything together. The public class, the class is, of course, like I explained today, the class is like a parent. Now the name of the class is program. Now it has static void, just like Java too. Void means string args. These ones are just the way of declaring the function in C#. Now you have the main as the name of the function. You have arguments that is supplying the string arguments, optional that you can supply. Then you have console, right line, hello. That's the console is like the class or object that is calling the function right line. Like I explained before, Okwe can call a hearing. So console is the class and it's calling right line hello world. The end of it is still calling console again. Console is calling another function called read key. Just like what Chidebere can do. Chidebere as an object can call his ear to ear, eyes to see. If he wants to see, you carry his eyes and you see. He wants to walk, you see this and move. So the same thing applies to this. Then finally you have the Kotlin. This is Kotlin. You can see the structure of it is the same. Now I'm not going to go deep into this, but what you can see here is the class. Then you can see super on create, set control, super on create, save instance state. Super on its own is a class calling a function called on create. Set content view is a function that is calling this argument. This is the first time you are seeing this kind of codes, but I believe with time you're going to understand them. Alright? Object-oriented programming in Python. Now, this is Python. You have class greeter. This is how to define function in Python. Greeter is calling this, see, is initializing. This is an example of initialization. Object is the instance of a class. Greeter. This is not the same as this. So, you know, this one is lowercase. This is uppercase. So when you get into programming, when you are writing this kind of things, you should know that this is not the same as this. This is the object. This is the class. Look at this is class. Is it not the same thing there? Yes. Are they not the same spelling? Yes. This is the class. You see. So this is the object. See, an object is the instance of a class. Chidebere is the instance of his father. This is the father now. This is Chidebere. Chidebere is calling what? The father. Call what? Greeter. Let's just assume that you are just. I want to bring it home. Opeyemi Abi. Let's say this is Opeyemi. This is Opeyemi. Opeyemi is now wherever she is, she's now going to call her father. Once this thing is done, this is what we call initialization. Once she calls this, everything belonging to her mom and her dad belongs to her. So here you now have the function and then the input. So that is that. Then for PHP, we are going to be doing that too. So for now, we are going to stop there. And then the next thing we are going to do now is, yes. So everybody, open that folder. Open the folder. Open the folder. Now you are going to see, come to your start menu like I said before. Open your start menu and then you type CMD. Once you type CMD here, look at it, comes up. Yes. Okay, is it up? Yes. So what you do is you move to this place. You run as administrator. Huh? Run it as administrator. Then you give authorization. Make sure you give authorization. Now when you give authorization, you're going to see this come on your computer. Now type Java C. Java. Look at the screen. It's on the screen. Java C. Then you press enter. You see, what result is it bringing? What result is it bringing? Look at it on the screen. You go to your start menu, you type CMD, and then you bring this up. Press enter, then it comes up. What is it showing? Can you read what it's showing? What is it showing? Assist this thing to do hard. The what? Careful. What's yours showing? Java C. Good. I mean, don't type Java C. Type Java C here. Java C. This one has Java. That's why it's showing that. Java C. Java C. Then let's change it. Are you see some of the challenges? They say some of the keyboards are not working. So I don't know how. Maybe you have to change. I'm not recording that. I didn't record that. Anybody that your own choose results, that means Java is one of the system. It's Java on this system. Okay, so now then the next thing you want to do, everybody, if you know you don't have a system that is working, pair up with someone whose one is working there. Then you come here, come to this space. You see this? Everybody look up. Come to this space, open this space like this. Is in the folder. The folder on the desktop. Have you seen it? The folder that was just copied to you from the flash on your desktop. So who can find it? Have you all seen it? Now this is what you have to open. This Eclipse Juno. Have you opened it? Everybody? Have you opened it? Huh? Open it. See, look at the screen, everybody. Look at the screen. That's why the projector is here to help you. When you open it, let me close it again now and open it. You double click like this, you open it like this. Huh? Then you see something like this. If something comes up, close that first one, then you open it like this. So what you do is that you now drag this thing like this, drag it and drop it. Inside of that same folder. It's already copying. Look at it. It's extracting. Look at it. When you drag and drop, it's going to copy. See, it's already there now. This is the folder, Eclipse. Because this is what we're going to use to test run our program, our first program. Is everybody on the same page? Okay, Amy, how far? You're doing it. Okay. You shouldn't isolate yourself. I told you to pair up yourself with somebody. You can't do it all alone by yourself. Are we on the same page? Can we go on? Sheye and Bube, please go around and just assist. Alpha. Mine is already done. Is everybody on the same page? By now, the extraction should be done. You're just supposed to drag and drop. You drag it from the WinRAR and then you drop it in that same folder. Are you going to? No, it's that same folder. Don't go out of that folder. It's that same folder. You can close on the command prompt. Close it for command prompt. Now, listen, can we go on now? Yes, good. Everybody look up at the screen. If I try to run this thing now, you see, it's going to show me something. Look at what it's showing me. Look at what it's going to show you. It's showing me, it says, a Java runtime environment, JRE, or Java development kit must be available in order to run Eclipse. You see, this is the kind of thing you encounter when you want to run Java. If you don't have the runtime environment, like what is rightly saying there, or the Java JDK itself, it will not run. This program will not run. So the only thing we can do right now is that all we have to do is that we'll come to this place, that same Diamond that Diamond Schools folder. You see, this is it. You now come to this program, everybody, have you gone there? Go to that place now. Some of you are still copying. Go to that folder. That folder that holds our files. Go back to that place. Eclipse. Anyone that is running that shows that your Java is running. Hold on for the rest so that you can join us. Once we run that program, we'll stop for the day. Have you lifted the programs? Have you lifted it? Is it there? We are trying to run it now. The Eclipse application. What's it saying? This Eclipse, complete the Eclipse app. No! Not there. I said the app, Eclipse app. Look at the app. Expand this thing. Look at this. Double click on it. And wait, you see? So, now anybody that tries to run and you are seeing that error, that means you are going to install a program. Everybody look up, please. Look up everybody. Look up. Now, what I'm going to do is I'm going to install the OpenJDK now. So what I have to do is I'll right click. Some of you are not looking up. Then you say install. So you wait for it. It is because this program is absent in computer. That's why you cannot run the Java program. Okay? So now we're going to run it. So it's saying, welcome to the Eclipse Temuring. Are we all there? You're there? Okpeyemi? Sorry, Olufemi rather. Are you there? Okay, so click on next. Follow my prompt to, don't go beyond what I'm doing on the screen. No. Follow my prompt. Then, here, you put will be installed on the local hard drive. Please, meet that guy. Chidebere, how far? Are you making progress?
Yes, sir.
Go and assist him. What are you guys doing? You're there. Good. These guys are in good. You see? Hello, come. Hello, what's that guy? Stand up. You're not doing anything there. You're not doing it. Hold on. Follow my prompt. If you are installing this thing, just follow my prompt.
Yes.
Okay? Good. Now, are you there?
Yes, sir.
I don't want to do anything here. Just follow, just see. Now, when you get here, you will do this. You have about 3 options here. Let me leave it to where you see it very well. You see, will be installed on local drive. You have options. Entire feature will not be available. The one you choose is, can you don't distract? You don't leave it. Now I've suspended that for now. This one is more important. Entire feature will be installed on local hard drive. I'm reserving the next battery for the next batch of people coming in. So then this one too, entire feature will be installed. Ensure none of them is showing X. And you select, have you done that? Entire feature will be installed. What we are doing now is that we are installing the JDK and the JRE. JDK, everybody right, is Java Development Kit. That's what JDK means. Java Development Kit. JDK. Java Development Kit. Kit. While the JRE is Java Runtime Environment. Java Runtime Environment. Hold on for the rest now. They might not be as fast as you are. JRE, not DRTE. It's JRE, Java Runtime Environment. Those 2 components are always needed before you run your Java program. They are always needed. Alright, so with that one, have we set? Yes. So we are all on the same page. So let's click next now, everybody. 1, 2, next. Are we there? Are we here? Don't do any other thing, no. Just follow what I'm doing. So now we are ready to install, Abby?
Yes.
Good. So we just click on what? Install. And you wait for it to complete. This video recording, the one I'm recording in, that one I've suspended it. The one I'm recording now, I'm going to hand it over to the principal. So that there's a way we're going to do it anyway. Because those guys are outside too now, they will need all these things. So it's being recorded. I'm going to hand it over to them. We'll play it back. Yes, exactly. Yes, say yes, yes. You say yes, please. Are you there?
Yes.
So, okay.
Finish. That's complete.
Yes, press finish. Now go back to your command prompt and type the Java now and see what you bring out. You see that there will be a difference now. Go back to the command prompt. That command prompt, CMD, the one at the start where you type something like this. Java, then you type JAVAC. You press enter. Good, so alright, now type who do you know to stay on your own? Join people, pair up with people who know who are doing these things well. You've done it, so what is he saying? Now the list is coming up. So if the list is coming up, that means you have been successful, you have successfully installed Java. What's your name again? What's your own saying now? Then you type Java C. Java C. Let me show you on the screen now because I just finished installing mine now. Run as administrator. Before it was showing cannot be recognized. So once I just type JAVAC and press enter, now it's giving the list. So this shows that Java has been installed. Good. So the next thing we'll do is we can close this now. Let's quickly go to the next thing. We are going to go back to that folder. Hello? Please go back to that folder now. Your Eclipse. Now run your Eclipse. You can now run your Eclipse. Yes. Come to this place and then double click it and run the program, this one, this application. You see, now when you look at a list, hello everybody, look up. Whenever you see something like this, when you see something like this, if you are running to run a program, you look at the list, the date modifier, then the type, the file type will show you the one that is application and the one that is not. Like this one is showing you the application, so double click it and wait for it. Good. Forget about that error it's giving you. I'm going to resolve that. Okay? Huh? Yeah, you can remove, of course. Just close it there. We're going to stop there for today. Then when you come next week, we'll continue. But please let me have the list of the names of people here now. Everybody take your I want to have attendance. Write down your names and then your class, so that the next people can come in and I'll take them. I hope others are here already. No, just leave it. Yeah, we still have people coming in. So we're going to just take them quickly as possible. So this recording, I don't know, I want to process it and forward it to your principal. Then you get a copy so you can play it back at home. Please quickly write it. So that others will come in. I'm